All right, so what I want to do real quick is let's do a demo and compare these two types of sort keys with each other. And we'll also compare it to a table that doesn't have a sort key. The sample data I'm going to use is the same sample data from before. This is available from this link. I will put that here. And this is actually a link to an article on AWS about comparing sort keys. The comparisons I'm going to do are a little bit different. They're more specific to something I want to point out specifically, but I would recommend as additional homework following this link, and if you want to do my demos or theirs, or do them both. It is interesting information. So we have that original line order table that was 600 million rows long. We're going to combine that with the customer table, and that is what is this customer sales date table. From there, I'm going to create two new tables. One is going to have a sort key that starts with date, then customer key, then region, then market segment, and it's going to be compound. And then I'm going to do it again, but this time I'll do it interleaved. Now, I won't make you sit here while these tables build. There is definitely something interesting that comes out of this result set. Building the compound sort key only took about 7-8 minutes. Doing the interleaved took all the way up to almost 26 minutes. So as you can tell, it is a lot more complex to manage and maintain an interleaved sort key. This is a good representation of the additional overhead required to maintain an interleaved key. All right, so what I want to do now is I want to find the maximum revenue and the minimum revenue across all three of these tables. That would be the interleaved one, the compound one, and then the original one that doesn't have a sort key. And we'll put it between a couple of dates. If you remember, the date is the first column identified in the compound sort key. All right, we got our results back, and I'll switch over here to messages. And it looks like running against the raw table without any sort key took about 6.5 seconds. The one with the interleaved sort key took 0.35 seconds, so quite a bit faster. But if you notice, the one with the compound sort key was even just a little bit faster than that. Now, 0.22 seconds and 0.35 seconds might seem roughly equivalent, but it is slower by a factor of about a third, maybe even just a little bit more. If you're working with a petabyte scale data warehouse, something that runs a third faster will become significant. Remember, we're only working with, I think the combined records out of this data set was something around 400 million. So still a lot of records, but by today's standards, that's becoming fewer and fewer. All right, the other example I have here is we're going to do the same type of query, max revenue and min revenue, but instead of using date, we're going to specify a specific segment, region, and customer key. Now on that compound sort key, we're skipping the date, so it's going to make that index quite a bit less effective. It'll be interesting to me to see what the speed of the interleaved sort key, which weighs all columns equally, will be. All right, so running that query with a customer key of 65,788 and then the region of Asia and a market segment of furniture, let's see what the results are across those three tables. Switch over to our messages. The raw table without any kind of sort key took 18 seconds to run. Now look at this. The interleaved search took 0.36 seconds, so a third of a second. Compare that to the compound index of 15, roughly 16 seconds for that third one. So doing a search against two columns in that compound key without including the full chain makes it about as slow as the raw table without any kind of sort key. Now it is an improvement, but it's nothing compared to that 0.36 seconds on that interleaved sort key. So again, interleaved is very, very effective, but don't forget about that additional overhead to manage and maintain. Now there's one additional thing that I'm kind of curious about. I want to see the storage footprint of these three tables. This is a query I got from AWS by way of Stack Overflow actually, but this shows the actual storage on disk of all my tables. If I go ahead and run this, what we see is that the test compound and the test interleaved tables are right about the same size on disk. So that additional overhead management is definitely related to internal complexity and not just sheer size. But look at the size of the tables as compared to the customer sales date, that raw table without the sort key. It's almost half the size. So this gives you something else to weigh, the balance of including sort keys, and this does grow with each additional column that you add. But this does give further evidence to the fact that Adding these columns is not without cost, both in terms of overhead management as well as disk space usage. But come on, if we're comparing a query time of 20, 30 seconds versus under a second, that could mean a world of difference to your end users and clients and customers.